Hello, welcome back to my channel, JBTeguihanon, Engineering and Chemistry Tutorial. So, let's study tonight refrigeration. Our course is refrigeration system. Our topic is energy. So, energy. So this is just a review. Again, this is just a review. So energy is defined as the capacity. Capacity here. Capacity to do work. Right? So this is a very common definition of energy. In other words, a system is said to possess energy when it is capable of doing work, right? So the energy possessed by a system is of the following two types. One is stored energy and two is transit energy. Transit means energy in transition, right? So energy in transition. Okay, so what is stored energy? Stored energy is the energy possessed by a system. Okay, sorry for that. Possessed by a system within its boundaries. Okay, the potential energy, the kinetic energy, and the internal energy are the examples of stored energy. Okay, we have two types of energy, stored and transit. The example of stored energy are potential energy. The guy is here, potential, kinetic energy, and the internal energy. Okay, let's continue. So, what about the transit energy? The transit energy, this guy here, or energy, transit, right? Energy in transition is the energy possessed by a system which is capable of crossing the boundary. Suppose you have a boundary, right? You have a boundary, a little bit late, so it becomes 2. So this is your boundary. If your energy is crossing the system, from inside it's going out, that is energy transit. Okay, energy transit. Okay, and this is your system boundary. Okay, boundary. Boundaries, right? System boundaries. System boundary. SP, you have them. No need to write down. Okay. So it may be noted, that only stored energy is a thermodynamic property, whereas the transit energy is not thermodynamic property, as it depends upon the pump. Okay, this is a big note here. This is not just a small note, this is a big note, right? Okay, let's remember that. Don't forget. Okay, so let's go in. So, types of stored energy. Potential energy. So potential energy, it is the energy possessed by a body or a system for doing work by virtue of its position above the ground or level, right? So suppose you have a stone. Okay, suppose you have a stone. I want to make a sketch here just to convey the idea. You have a stone at rest with a mass M. This is a stone. This is not an M, but a stone. And then it is there at that location. And somehow you have a lower state here. A location where it is below the stone. M. So they have the difference of elevation, which we call Z, right? And this is, so with respect to Z, with respect to this, okay, the potential energy of mass M. So this is a stone, has a mass M, and it has a weight actually. And the weight is somewhere here, right? And the weight is equal to, W is equal to, so sorry, so how can I do this? How can I do? So anyway, your M, so it was deleted by mistake, and there's no way I can undo it. Wait a minute. Right. So no, I cannot. Yeah, there is no undo. Anyway, yeah, if we use that, oh no, maybe I made mistake. So maybe it's yeah, sorry, it goes up. So if you have you have W, and your W is expressed, or your weight is equal to actually mass times mass M, okay, your M I will rewrite it. Your W is equal to mass of your stone times the gravitational acceleration G, right? Okay, so by formula, this is just a review anyway. So by formula, your potential energy PE is equal to weight times Z, and your weight is expressed in M times G times Z. So therefore your potential energy is this M times G. Your G is acceleration due to gravity, that is 9.81 meter per second square for SI, and that is 32.2. Okay, 32.2 feet per second square in English system or engineering system. So meaning if you are asked to find for the potential energy and the mass is given and the Z is given, then you assume that G is supposed to be 9.81 meter per second. If there is a given, then use the given to calculate the potential energy. On the other hand, if M is not given but weight is given, then use weight, then right away multiply it by Z, and you can also calculate the potential energy. So we have note here A and B, right? When W is in Newton and Z in meters, the potential energy will be Newton meter. It's talking about the unit here. B, when M or mass is in kilogram and Z in meters, then the potential energy will be in Newton meter as discussed. Yeah, don't be confused, okay? Don't be confused with that. That's unit. Okay, we know that potential energy is M equal to M times G times Z, and unit analysis, the unit of M is in kilogram, the unit of G is in meter per second square, and the unit of Z is in meter. Okay, and that is actually kilogram meter square second square, and that is Newton meter. Okay, this might be given, no, as in a board exam for the unit analysis. So this is very important. So therefore 1 Newton is equal to 1 kilogram meter second square. Yeah, this Newton here. Okay. This is the unit of potential energy, Newton meter. But the equivalent of Newton, 1 Newton is equal to 1 kilogram meter second square. This is what he's trying to tell us. Okay, thank you. That's all for now. Thanks for watching. Please subscribe to my channel, JBTeguihanon Engineering and Chemistry Tutorial. Bye, God bless.